Hey guys, we are starting off with our next chapter, and it's all about polygons, and then specifically we're going to get into talking about quadrilaterals. So the first thing we're going to do before we actually get into the notes is do this investigation together. So hopefully you can name all of these polygons that you see in front of you. I would love for you to fill in all of the chart that you can before you see me fill it in. So if you need to pause the video, you can do that. See if you can fill in and come up with some of those angle measures and come up with your rule. At the very least, you should be able to fill in this one. Type of polygon. 3-sided is a triangle. 4-sided is a quadrilateral. We can't get more specific than that right now. A 5-sided is a pentagon. And a 6-sided is a hexagon. Okay, so, and I'm going to leave this bottom row blank for a little bit. We'll talk about it in just a minute. So, for our investigation, a triangle we know has 3 sides. We want to know how many triangles we can form if we draw a line from one vertex to the other vertices. So we just pick a vertex and draw it to the other ones. Well, no matter where you pick, like if I pick this point up here at the top, if I draw it to the other vertices, I haven't formed anything new. It's still that one triangle. So we have just one triangle. So sum of angle measures of the triangles then would be 180 degrees since we have one triangle. So 1 times 180. The sum of the angle measures of the polygon then, well, the polygon is a triangle, so that would be 180 degrees. So now if I look at the next one, a quadrilateral has 4 sides. I'm just going to pick one vertex. And if I draw to the other vertices, how many triangles have I formed? And I can see that I've cut that into 2 triangles. So I formed 2 triangles. So in each of those triangles, they add up to 180 degrees. We know that from our previous chapters. So then we have 2 triangles times 180. And so 2 times 180, the sum of the angle measures of the polygon would be 360. So a pentagon then has 5 sides. I'm going to pick, and it doesn't matter which vertex you pick, but I'm going to draw to the other sides, and I'm only drawing to the ones that aren't already connected. But I notice that I have 3 triangles in there. You start looking, you should see a pattern there. So then if I have 3 triangles, which all add up to 180 inside, then 3 times 180 gives me 540 would be my total degree measure. So 540 degrees. All right, let's see if we can fill in hexagon. Hopefully you're noticing some patterns here. A hexagon has 6 sides. I would guess based on our pattern, we can probably find 4 triangles in here. Let's see. So straight down to this one, right over here, and right here. And look, we have formed 4 different triangles. So those 4 triangles each have a sum of 180 degrees as our angle measures. So 4 times 180 would be 720 degrees. Okay, so let's see if we can come up with a rule for this. So I'm going to call this our n-gon. So an n-gon has any number of sides n. So you'll notice we went 3, 4, 5, 6, then we went 1, 2, 3, 4, but we're not necessarily jumping to a 7-sided figure. This is any number of sides. So if I look, though, from 3 to 1, from 4 to 2, from 5 to 3, from 6 to 4, I notice that I've subtracted 2 every time. So I take the number of sides that I have and take away 2. And that's how many triangles I can form in that polygon. And then I noticed that I multiplied by the number of triangles times 180. So here would be n minus 2 times 180 would be my expression to get to the sum of the measures of the polygon. So this would also be n minus 2 times 180. And notice that I have grouped that n minus 2 together. We want to make sure we take care of that. All right, so let's see how we're going to use this. It says the sum of the measures of the interior angles of a convex polygon is, and that's the rule we just developed, n minus 2 times 180. So our first example says find the sum of the measures of the interior angles of a convex hexagon. Okay, I know we just did that on our investigation, but let's see if we can get there based on our rule. So a hexagon has 6 sides, so I'm going to do 6 minus 2 times 180. So 6 minus 2 gives me 4 times 180, and 4 times 180 is 720 degrees. Okay, corollary to the theorem, the interior angles of a quadrilateral is 360 degrees. That's just telling you this is one you should know. You shouldn't have to use the rule to get there. We know that a quadrilateral is going to add up to 360. Okay, the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by the number of sides. Okay, well we only know one formula so far, and that's n minus 2 times 180. It's saying find n, find how many sides we have. If we know the answer to this is 1,260. So in this case, you could distribute that 180, but I would tend to divide both sides by 180. And then I'm left with just n minus 2 over here, which I think is nicer that way. And we get 7 on this side. We add 2 to both sides. N equals 9. But it says classify the polygon. So I don't want to know that it's a 9-sided polygon. I want you to think back to last semester and tell me that it is a nonagon. That's our 9-sided polygon. Okay, find the value of x in the diagram shown. So, in this diagram, we have a 4-sided figure. We know that they should all add up to 360. So just like we did with triangles, we're just adding up all of the degree measures and setting it equal to 360. So I have x plus, and then if I combine all of those, 71 plus 112 plus 135, I will get 318 equals 360. So subtract 318 from both sides, and I get that x equals 42 degrees. Okay, now what if it's not one that we know? Well, we need to stop and say, okay, this is a 5-sided figure. So I'm going to use my formula. 5 minus 2 times 180, 3 times 180. 3 times 180 will be 540. And then I'm going to use that and say 68 plus 105 plus 109 plus, now I don't have variables for these, but I know they're the same since they have arcs, so I'm just going to call them both x. So plus x equals 540. So 68 plus 105 plus 109 gives me 282. Plus, I have 1x plus 1x, so 2x equals 540. I'm going to subtract 282 from both sides of the equal sign. So 2x equals 540 minus 282 is 258. Divide by 2 on both sides. X is equal to 129. So the measure of angle K is 129 degrees, and the measure of angle L is 129 degrees. Okay, another theorem we have is the exterior angles theorem. It says the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So this is just something you should know. It's 360 degrees. It never changes, no matter how many sides we have. So if you get something like this, we know that we can immediately add up all of those exterior angles and set them equal to 360. So now I have 1x plus 2x, which gives me 3x, and then I have 89 plus 85. So 3x plus 174 is equal to 360. I'm going to subtract 174 from both sides, and I get 3x equals, and 360 minus 174 is 186. I'm going to divide by 3 on both sides, and I get x equals 62 degrees. And it says find the value of x. That's all we had to do. We don't need to find that other angle. Okay, this last example says the base of a lamp is in the shape of a regular 15-gon. Find the measure of each interior angle and the measure of each exterior angle. So if we're talking interior, I only know one formula, and that's n minus 2 times 180. So this was problem A. Well, the n value in this case is 15, so 15 minus 2 times 180. So I have 13 times 180. So 13 times 180 is 2,340. But what that just told me was the sum of the interior angles. I want to know each interior angle. So then I need to take 2,340 and divide by the number of angles that I have. In this case, I have 15 angles. So 2,340 divided by 15 is 156 degrees. Okay, then part B. We want to find each exterior angle. We know the sum of the exterior angles is 360. That's the total. We need to take that and divide by the number of angles that we have, in this case 15. So 360 divided by 15 is going to give you 24 degrees. Alright guys, we'll practice some more in class with this stuff. If you have questions, please don't hesitate to come in and see me. Have a great day.